Electricity is invisible, so how can we picture it? And if we can't picture it, then how can we understand it? Well, I'm going to help you with that. We're going to look at charge, current and potential difference and explain all three. Electric charge is just a property that things have. They can be positive, negative or neutral, and what it does is it describes how they interact. Like charges repel and opposite charges attract. We can think of it as the electrical quantity. In fact, that's what the French called it, and that's why we give it the symbol Q. The charges carry energy from the battery in a circuit to the components. I like to think of the charges as like the luggage space in my car. Well, actually, my car doesn't have very much. A van would have more. So it's like, how much energy can I put into the back of a van? That's really what I think of charge as. So just like the van compared with my car, the larger the charge, the more energy that can be carried. So charge is just a physical property of matter. Now let's have a look at voltage. The voltage tells us how much energy each charge is carrying. The amount of energy in a charge is that's called the potential. And we can look at the potential difference between two places on the circuit using a voltmeter. And that potential difference is measured in volts. It's the difference in energy of the charges. Take a look at this diagram. This voltmeter is connected across a battery. It's just telling us the difference in the energy of the charges either side of the battery. It's got 6 volts, this one. 6 volts just means each unit of charge that goes through the battery collects 6 joules of energy. Because we need to measure the potential difference between 2 points, the voltmeter needs to be connected in parallel between these 2 points. What if we now extend the circuit so there's 2 lamps? Each charge, now carrying its 6 joules of energy, now flows through both lamps. So how much energy does it give to each lamp? Well, it gives 3 joules. The potential difference between either side of each lamp is 3 volts, making a total potential difference of 6 volts. So the charges can go and collect another 6 joules of energy. So the potential difference across a component in a circuit is just how much energy changes as the charge goes through that component. We give potential difference the symbol V. Before I briefly explain current, let me point you in the direction of my website. On there's loads more free resources, as well as information about revision courses and one-to-one lessons. Do also comment on the video. I love to read your comments and suggestions. Right, now back to electricity. The electric current is just the rate of flow of charge. It's the amount of charge that passes a point each second. We can measure it with an ammeter. We plug the ammeter in the circuit and it counts how much charge flows through it per second. For that reason, we have to connect the ammeter in series, actually in line in the circuit. The more current that flows, the more energy can be delivered. This means that components and wires and things can get quite hot when a lot of current flows. Now, once again, the French have a hand in choosing the symbol for current. They called it the electrical intensity, so it's got the symbol I. So charge has the symbol Q, potential difference or voltage, the same thing really, has the symbol V, and current has the symbol I. Notice they're all capital letters, they're all uppercase. That's important so we don't get them confused with anything else. Now we have an idea of what electric current and voltage are, we're going to apply some equations to those in my next video. So please do subscribe and like, it helps support the channel. And don't forget my lessons and courses and free resources on my website, videoplatoacademy.com. Right, now watch this.